You go. The definition of a synthesis reaction is when less complex compounds come together. So say if I was to come to Lizzie and Lizzie was to come to me, and me being A, with me being A and Lizzie being B, we are reactants and then stop laughing. We are reactions and me and Lizzie, we both make a product. So A plus B equals AB.
Also, another very good example of a synthesis reaction is Colin eating this piece of pizza. Let's say Colin is A, and the piece of pizza is B, and it is going in his stomach, and since it's becoming inside of him, it is becoming together as one. So it is somewhat of a reaction because you have two separate things, two separate compounds, and they are coming together to form one single compound. And yeah, that's a synthesis reaction.
Decompensation. Decomposition is when two compounds heat up against each other and 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 they split.
She left you.
She left me.
So the definition of a decomposition reaction is when a compound breaks apart into either elements or less complex compounds. And with Colin having that slice of pizza in his stomach, he is considered A and B. And as he is uneating this slice of pizza, Colin is becoming more A, and the piece of pizza is becoming B. And as you can see, the skeleton of the reaction is A and B is equal to A plus B. And that's all we got for a decomposition reaction. Up to the next one.
So a single replacement reaction is when a single compound replaces another one. So I have Olivia, so I'm going to be A, she's going to be B, and Colin's going to be C. So, it's going to be A, B plus C. Oh, sorry. And now, if she goes to Colin, I'm all by myself, and now if she goes with Colin, it's going to be B, C plus A.
So the Pepsi can is A and B, A being the can, B being the Pepsi, and that cup that's all empty, that is considered C. So as I'm pouring the liquids, or B, into the empty cup, C, it is becoming BC plus A, and before it was AB plus C. So now the skeleton of it is...
So a double replacement reaction is when ions switch temporarily or permanently. So say if I was A and B, C and D as the reactants, after the double replacement reaction, after the reaction occurs, it would end up being A and D and then C and B.
Because I have the little cup with Pepsi, I am considered A and B. And with Colin right next to me, it's going to be plus C and D. As you can see, we switch off cups because we do not like what we are drinking. And now I am considered A and D, and Colin is considered C and B. And we both turn out great, and we like our drinks. So for a combustion reaction, we have CX and HY plus O2. X and Y being different numbers, and as you can tell, it turned into CO2 and H2O, And that is basically what combustion is. It's when you end up with CO2 and H2O. I did some peeping around on YouTube, and thanks to this guy right here, I found a video that might explain what combustion is all about. So enjoy it. So you need some sort of energy, active energy. You also need oxygen, as you can see, and fuel, some sort of fuel, and they combust. So basically, you can see at the bottom, or you saw at the bottom, the skeleton of this, and if you add a fuel source to this, it turns into CO2, and at the bottom of the cup, you can see a little residue of H2O. At this moment, you can pause and read the explanation of each reaction. Now it's time to take a quick quiz. Pause the video so you guys can answer these questions.